What's good, everyone, and welcome back to another video. This video is going to be on the final module, module 4 for the course 1, before moving on to course 2. Okay, so final section of the course where it's going to shift from concepts to practical tools. It is going to talk about security tools and programming language. They're essential because they help monitor security, automate repetitive tasks, improve efficiency and accuracy. So you're not expected to master them yet, but this module is just like the exposure and the foundation of it. You're also going to be introduced to security monitoring tools like the SIM tools, playbook, network protocol analyzer, operating systems and programming like Linux, SQL, Python. And then these tools are commonly used for search data, identify trends, automate security tasks. It also shows logs, which is think of logs as the foundation. A log is a record of events inside systems. Some example would just be user logins, access to web service, network activity. Why it matters. It helps analysts basically identify vulnerability, detect suspicious behavior, investigate security breaches. So, yeah. Tools don't really replace logs, they organize them. SIM tools. What is a SIM? A SIM tool collects log data from many sources, analyzes it in real time, and then it generates alert for threats and risk. Why they are basically critical. Without SIM, analysts would have to manually review massive log files. Detection could take hours or even days. But with SIM, alerts surface important events immediately, and then the analyst can just focus on the risk and not the noise. Some of the common SIM tools would be Splunk. That's a data analyst platform. Google Chronicle, which is a cloud-native SIM. So both tools filters events, help teams respond quickly, and things like that. And how analysts use SIM, they just review alerts, analyze event patterns, perform incident investigation, and then proactively hunt for threats. They talked about playbook. So what a playbook is it's a documented guide that explains what to do before, during, and after an incident. So the playbook exists for security incidents, compliance reviews, access to management, and also operational tasks. So playbooks ensures consistent, ethical, and legal responses. Playbook number 1 with chain of custody. So chain of custody is the process of documenting evidence, possession, and control throughout an incident. You must record who handled the evidence, what the evidence is, where is it being stored, why is it being accessed. And then the rules are evidence must be tracked at all time, every transfer must be documented, and evidence is your responsibility while it is in your possession. So if you break the chain, then the evidence becomes unreliable. We also have playbook number 2, which is protecting and preserving evidence. So for these, it would be why this matters. Digital evidence is often fragile or volatile. So if the data can be lost if let's say a device powers off, a system restarts, or memory clears. So order of volatility, a priority sequence that determines what data must be preserved first and what can be wait. So the first priority would be preserve data before investigating it, right? The best practice, which would be make copies of the evidence, investigate that copy instead, and then just keep the original untouched. Improper handling can alter evidence, invalidate investigation, and avoid insurance or legal cases. Network protocol analyzers, or package sniffers, not packer. Sorry about the typo, it's package. So for this one, it's A packet sniffer is a network protocol analyzer that captures and inspects network traffic. It's used to detect suspicious activity, analyze data flow, investigate incidents. Some common tools would be TCP dump, which is a command line tool, common on Linux system, or Wireshark, which is a GUI based package analyzer. Obviously, same thing. You don't have to. It's not like you need a mastery on it. Just familiarly. You get familiar with it when it comes to like practice. However, if you have already done like, let's say a class on computer science network, then you kind of know like certain things already. Afterward, it moved on to programming language and operation system in security. And so in a big picture, security analysts don't just rely on tools alone like SIM. They also use the programming languages and operating systems. For that is to automate repetitive tasks, reduce human error, and analyze large amount of data efficiently. So why programming matters in security? It allows analysts to basically create instructions for the computer to follow, automate tasks that would take hours or days manually, reduce mistakes by oversight and stuff. Some examples would just be like searching logs, filtering dataset, detecting patterns, or repeating investigation consistently. And then it talked about Linux operating system. So a Linux is open source, is publicly available, it's widely used in services and security environments, primarily command line based. So Linux is not a programming language. Okay, it's an operating system. Why analysts kind of use it? Since it allows analysts to basically run text-based command, examine system and network logs, and investigate issues directly on service. SQL, however, is a language, and it's used to basically create databases. You interact with the database and then query like specific data from large data set. So in a database is an organized collection of data, often containing millions of records. How security analysts use SQL is to basically filter those massive data set, retrieve specific events or user actions, and then analyze trends in the log and alert. Python is also a programming language, not the snake. Python is a general purpose language widely used in security. Why is it popular? It's just they use Python to automate repetitive tasks, handle detailed and precise processes, build scripts for log analysts, alerting, data phrasing. So it's not just Python, but this course is on Python, and that's their way of saying just use it. And plus, it's one of the more popular languages too, so I guess it's understandable. Okay, afterward, it talked about basically the things like web vulnerability, antivirus / anti-malware software, things like that. So what is a web vulnerability? Web vulnerability is a flaw in a web application that can allow like unauthorized access, data theft, or malware deployment. And so antivirus or antivirus software. The purpose is antivirus software prevents, detects, and eliminates malware and viruses. And how it works, it just scans memory and files, looks for known malicious pattern. Intrusion detection system, IDS. It monitors systems and network activity, analyzes network package, alerts on possible intrusion. So IDS can detect unauthorized access, data theft, or suspicious behavior. There's also a little bit on encryption. So encryption protects data by making it unreadable for unauthorized user. So The key terms would be like you have a plain text or just something that's readable in data, right? And then a ciphertext. So the ciphertext is going to be encrypted data, and the primary goal is for confidentiality. So, and encryption converts plain text into a secure ciphertext. Penetration testing. So a pen testing is a simulated attack used to basically identify a vulnerability, evaluate security weaknesses, access internal and external threats, and the pen testing examines systems, networks, application, and processes. Okay, so it's not malicious hacking, but it's just a proactive defense. So that's basically all for that. And then on their final part, they talked about how to create a cybersecurity portfolio. So a cybersecurity portfolio is how you can prove you can do the security, not just talk about it. So a resume summarizes, a portfolio demonstrates. Employers can just use portfolios to access the skill, your thinking process, your passion for security, I guess. And so, it's sort of like how you can prove you can do the security, right? And a portfolio is a collection of security projects, labs, documentation, written analysis, evidence of on-hand skills, And they talked about different options. One being, these are the 4 options that they talked about. Documents folder, local, a folder that stores on your computer. And so, you keep everything organized. Cloud storage, like Google Drive, Dropbox, this is document storage. Web builder, like Google Sites. You can create a professional website, custom layouts, all publishing it, all that. And then finally, Git repository, like GitHub or GitLab. You store like the lab's documentation, screenshots, projects, all that. So portfolio projects you build in this like program is basically you have like a real portfolio ready artifacts, which includes like professional security statements, basically everything I mentioned, kind of, it's kind of sort of like they talk about this for you to sort of like do it, and like it tells you exactly like these are exactly what the hiring managers want to see, I guess. I kind of created it, but I don't know. It seems kind of small right now because it's only 1 paragraph. But we'll see what's happening afterward. But for now, this is all they have, and yeah, this is the last slide. There's nothing else. You get the idea. It's sort of just the cybersecurity portfolio kind of just shows employers that what you can actually do. So it's not like a resume where like it sort of like includes hands-on projects, audits, and investigations that demonstrate like actual skills. And so, there's that. Anyway, that is it for the video. I will be making a video on course 2. If not, I'll do, or before course 2, I'll probably do like a leak code problem because, I always got to do what I got to do. All right, thanks for watching. Bye.